Good day, everyone. Thank you for joining us today and the reactor for this wonderful presentation by Carlos Robles in regards to SQL containers in Microsoft Azure. Thank you again, and we will hand the floor over to Carlos.
All right. Can you hear me okay?
Yep, loud and clear.
All right, just making sure you can hear me. All right, thank you all for attending this live presentation today, and also thank you for those watching the recorded version of this presentation, and also thank you Microsoft Reactor for this opportunity. The topic today is SQL containers in Microsoft Azure. My name is Carlos Robles. I am originally from Guatemala, living in the United States for the past 2 years. I have more than 10 years of experience working in the field of database administration for multiple platforms. Nowadays, working as a solution architect for on-prem or cloud environments. I have the honor to be a Microsoft Data Platform MVP and a friend of Redgate as well. Speaking about my community work, I happen to be the Guatemala SQL Server user group community leader, and yes, I do this work remotely, and it's worth it, trust me. I have a few published articles in the internet for Redgate, Simple Talk, SQL Server Central, and SQL Tips. Most of them are related to the SQL containers topic. And finally, I represent my blog consulting company called DBA Mastery. You can find a lot of content on my blog, or you can check my GitHub repository for some open source tools I have developed in the past. But the most important thing, you will find slide decks and scripts for today's demos in my GitHub repository. Most important thing of this slide is my contact information. If you want to connect on LinkedIn, or if you want to ping me on Twitter, or in case you want to send me an email to follow up something, a question for today, please do it. I am open. Okay, so today we're gonna have, I think, around 60 minutes to talk about SQL Server containers in Microsoft Azure. My goal with this presentation is to show you why ACI and AKS are the easiest ways for you to run SQL Server containers in the cloud today. Okay, and the first topic is obviously containers. What and why? A brief definition of what a container is and why containers are so good to build immutable infrastructure solutions anywhere. Okay, then I will focus to talk about containers from the SQL Server perspective, to finally focus on today's topic, which are Azure Container Registry, Azure Container Instances, and finally Azure Kubernetes Services. Okay, here's a brief introduction for today's presentation. There is a really big opportunity right now, excuse me, especially for containers in the cloud, because Gartner believes that in the next few years, we are going to see around 75% of the companies running mission-critical containerized and cloud-native workloads in production. That means that there is a lot of chance for you to be at the top of this transformation, as well to join Azure in this journey to containerize all the things. Okay, let's jump to the first topic. What are containers? Well, they are commonly called a standard unit of software for a very good reason. Excuse me again. It's because a container image can include all binaries, libraries, and all files and dependencies that makes our application functional. Containers, a difference than with VMs, shares the machine's OS system kernel, driving higher server efficiency, but more importantly, reducing storage footprint and server licensing costs. They are cross-platform. A container created in macOS will run the same on Linux, Windows, or even in serverless services like Azure Containers instances. So the question now is, why containers? For those that are new to this world of containers, there is an added value that containers provide over VMs or even function as a service. One of the key things are speed. Containers do not require to load an entire OS per application, leading to very quick start and stop times, which is very convenient for developers. I'm not saying containers are meant to replace virtualization technologies. They're just another tool in your toolbox that is available for you whenever you have a software problem. You can leverage this cool technology to solve your problem. Okay? Containers are really simple. They just includes the application and user space. And by all means, that's a lot simpler in terms of overhead. They are mostly managed by API tools, which makes them really easy to learn and use. And finally, the packaging. That's a really interesting characteristic because you don't have to worry about including all their dependencies, all your files, and everything back in your application deployment. Worry no more. That's possible with containers, just specifying all those dependencies and files in a single file. And this file is called a Docker file. That makes things really easy for us, right? All right, so let's talk about SQL Server containers. If we stop for a moment to think about the role of databases in today's IT world, we can easily say that databases are pretty important, right? Honestly, I cannot think about an enterprise type application not having a database behind to store important stateful data. As I mentioned at the beginning of this session, organizations are moving towards containerized applications, but what is very likely that they would like to include SQL Server as part of this new development stack. And in this case, we're talking about containerized workloads, of course. DevOps demands agile and automated ways to build pipelines for development, stage, QA, or even production environments. And that's quite challenging to achieve when using a monolith development practice. Developers are in the need of simple runtime workplaces, excuse me, where they can have a SQL Server instance integrated as any component of your application, and most importantly, to be able to manage this infrastructure to code. So there is when containers running on Docker and Kubernetes come to light to provide you that portability, that agility to run modularized applications on premise or even the public cloud like Azure. Okay, so this session is about SQL containers in Azure. So you will say, how? Well, I will provide you a brief introduction to what Microsoft Azure offers in terms of containerized workloads in their platform. But the most important thing, I will focus on highlighting through the demos that durability and network connectivity and high availability we are always looking when running any SQL Server workload. In this case, it's in containerized workloads in the cloud, okay? So Azure provides us a few user experiences to interact with containers in Azure, obviously. The first one is the graphical UI as the Azure portal, of course. Then we have the Cloud Shell, which is a terminal we can use directly on the Azure portal. We also have the Azure CLI. It's a multi-platform CLI that runs and connects to Azure, and you can manage all your infrastructure from there. And now this is kind of new. I think it was released a couple of weeks ago. We have an integration between the Docker client desktop, excuse me, Docker client, specifically the CLI, and Azure Container Instances. So we will see a little bit of each one of these tools during the demos. So hopefully we will learn more from there. Okay. So the first topic is Azure Container Registry. A registry is a concept that allows me to pull things with a content addressable URL. In the container case, that container are images. Imagine an infrastructure project. the very first thing you will probably build is the storage. Okay, so ACR ends being a fundamental component to the overall container ecosystem in Azure. It allows me to manage a private Docker registry as a first-class Azure service where I can still use my Docker CLI commands that I am used to work in order to build, tag, or push images from my laptop or some, excuse me, continuous integration platforms as Azure DevOps, Jenkins, or even scripts from my machine. Okay. It provides geo-replication, which I think it's a really cool feature. It takes a couple of clicks to set up this feature, and you will start replicating instantaneously all your Docker images from one region to another. Once these features enable, it will also allow you to pull an image from the closest registry that you are replicating to. And this is very important for cloud native applications. I mean, from the business continuity standpoint, because it enables you to recover your entire image repository in case of disaster. Okay. All right. So next topic is Azure Container Instances. Excuse me. This service enables you to run containers without ever touching a server. If you run containers today, you probably set up your own virtual environment to install Docker, or maybe you are looking to do it in your laptop. However, if you're running Windows Home, for example, you won't be able to run Docker Desktop there. I know there are more options nowadays as WSL2, which is really cool. But anyway, you will need to have resources to run your containers in your own laptop. With ACI, you can say, okay, I have this Docker image and I just want to deploy it somewhere. I don't want to know anything about the VMs, anything about the resources. I just want Azure to take care of everything for me and run this container somewhere. And that's exactly Microsoft's goal. And they want you to look at containers as the new compute primitive, exactly the same way we see VMs today. Exactly the same way you interact with VMs in the Azure portal, the same way you use RBAC. So Microsoft is kind of making sure to provide you that same user experience with this service. On top of that, Azure let us define our own configurations instead of going to a VM configuration SKU set. You can define exactly how much CPU or memory you need. I'm going to give you an example. For example, you need a really, I would say, low-ending, not so powerful container, which 1 gigabyte each for memory and CPU. You can do it. And ACI is so flexible because of micro billing. Azure will bill you by the second for each one of those resources you pick until the container is deleted. The last component is secure hypervisor isolation for each of your containers that will be implemented using the same security model as VMs. And I would like to make a pause here just to share something really quick. Remember I said that the ACI is really flexible and lets you pick how much CPU memory you want. This is a real world scenario where I had a friend, he come to me and asked me, we are a very small shop. We don't have resources. Our servers are we don't have any capacity. We don't have any compute CPU or memory available to put some new SQL servers there, and we need to create a new feature. How we can achieve this? So they use ACI and they relied into this technology to create those new features for the new development, and they were able to do it really quick. Okay, so why ACI? Invisible infrastructure has a larger meaning. The first thing we need to understand here is that there are actually no servers. Containers are running in the cloud, of course, but the server infrastructure is invisible for us. But let me clarify here. It doesn't simply run on paper or vapor. There are some servers somewhere in Azure's infrastructure, but the cloud abstraction has chosen to hide it from you. We simply don't care about any overhead costs to those servers in Azure infrastructure. We just want our containers, in this case, our SQL Server containers, to run and be able for us and be available for us. Microbillion, as I said before, it means that we can get higher CPU and memory utilization than VMs. Once again, imagine this scenario. You have this request that would take your developers a few days to complete, and you need a SQL Server instance to be up and running for a couple hours during those days. You don't need a dedicated VM for that. You can just deploy a container with exactly you need. You will get 100% utilization, and then just take it down whenever you're done. And those are great advantages of immutable infrastructure, which leads me to the next characteristic. In this case, it's modularity. Being able to scale out some of the specific areas that might become a bottleneck in the future, it is just beautiful. Let's imagine you have a front end, a back end, and a database on your new development, and you need to scale out just the backend piece of your your deployment. You can do it. You can scale up and scale down your containers at will. And once you're done, you can just get rid of everything and you won't be build it anymore. So as I said, this is a real world scenario where I participated in this case where this development team get 100% utilization for a couple of days of a SQL instance running on an ACI, and that's it. Okay, so let's have a demo of how to run, how to integrate ACI, and monitor our containers in the cloud. So let me switch back to where it did go. It's here. All right. So I have multiple demos today, and I used to have one demo. It's here for you guys to follow up. You can, as I said, I will share my GitHub repository. This is very straightforward. It's about creating a custom image for MS SQL tools, and I was creating this customized image to run SQL command anywhere on a container. I will skip this demo for a very good reason, because as I said, Microsoft I would say there was like this cooperation between Docker and Microsoft to integrate ACI into the Docker client. So I think that's more important than creating a custom image. Here's the example. You can follow this along. It's not complicated. It's just about doing a build and doing a tag and pushing this image into ACR. So I will start with ACI, Azure Container Instances, and we will start with the Azure CLI commands. Okay, so here's an example of what I'm going to do. I'm going to create this container from the Azure CLI client. We're going to check the logs. I will check some of the properties of this container running on ACI. I will connect. I will show you how to get the IP, how to connect using Azure Data Studio. We'll explore the instance to make sure this is a SQL Server that we love and know. And then finally, I will do some basic container lifecycle management. All right. So the first thing is that we have to create our container. I will be completely honest with you. Creating ACI container takes between 1 minute and a half and maybe 2 minutes. It's because obviously Azure has to provision these containers somewhere and it needs to be nearest to your location. So it takes from 1 minute and a half and 2 minutes. So I will skip this for now, but I will focus. Here's the command if you want to do it. It's really simple. I will focus to highlight a couple of things here that are very important. Everything is straightforward here. We have a resource group. We have to say, okay, Azure container create my resource group, the name of my ACI, the Docker image, then the any environment variables. In case of SQL Server, we have to accept the end user license agreement and the SA password. We have to set the SA password. Okay, a DNS label. This is optional. If you are, I don't know, if your implementation has some VNets and you want to keep your infrastructure secure, I will highly recommend to use VNets. And in my case, I need to connect really easy. So I'm creating this DNS label so I can connect from the internet. So have a public IP. This is really important about ACIs in regards of SQL Server. There is some memory, or I would say system requirements for SQL Server running anywhere. So we need to make sure we fulfill those needs. In case of SQL Server, we have to have at least 2 gigabytes of memory and at least I believe a couple of CPUs. I'm not entirely sure, but you can take a look here. So in my deployment, I am defining that I want to have 4 CPUs and I want to have 4 gigabytes of memory. And of course, I'll use the port 1433. And if you are familiar with SQL Server, 1433, it's the default port for listening into SQL Server. So let's imagine I run this. You will get this JSON. This is very nice because you will get all the properties and everything you define in your deployment. So we can take a look here. I have my environment variables. I have the image I use. Here's the count. This count is important when using a multi-container deployment. In this case, I'm just deploying in one container. Some metadata, and so on and so on. So really nice. But what about if you want to, I don't know, for some reason, check the logs, make sure everything is okay. So you can do it. You can use this command. You will see a lot of logging failures here. That was me, and that was expected. I was using something to connect to this container. Yeah, I have so many tries, and I had this application trying to connect. So that's okay. But at least you have a way to monitor what's going on from the CLI. Okay, and what about learning about those properties? I see, I got this JSON that was returned when I created my container, but what about if I want to take a look at that later? So you can use this list. Let me address here. There you go. I think, yeah, that's a little bit better. Yeah, I know this is, let me run it again, and I will use the zoom feature here. There you go. So this is nice because you get the name of your containers, you get the resource group. Obviously, I am listing every single container on my resource group, so I get this information for all containers, but you can see I have the IP, I got the ports, the network. In this case, I'm using a public IP. I don't have a VNet, how much memory it is allocated to each one of these containers, and the OS type. I'm using Linux for every single container I deploy today. Okay, let me clear this out. Let me go back to my normal. I think it's okay now. All right, there you go. Okay, so what if I am interested to see the properties for my container? I can do it. I can just filter by the ACI. I'm interested to see. I can get the JSON information returned. So if, in case you need to, I don't know, automate something or use this information, of course, you can always, because this is JSON, we can use some queries to get some specific information. For example, the IP, the fully qualified domain name, and so on. So there is many stuff you can do here. So why this is important? Well, this is important for me because I need to connect. This is a database, so I need to use a client tool to connect and start doing some development. So in my case, I'm running macOS, so I need to use a tool, and I choose to use Azure Data Studio, of course. This is a multi-platform, cross-platform and database development tool you can use. So let me show you. Okay, imagine I grab this DNS. So let me jump to Azure Data Studio, and here you go. I will show you something really quick here. Connection. Okay, so here's my the name of my server. I'm putting the SA login and the password, of course, and that's it. That's all you need to connect to a SQL Server instance running on an ACI. It's, as I said, is the same SQL Server we love and know. And let me do something real quick here. There you go. This is kind of a dashboard where you can see what's going on. Um, we can see some information and stuff like that. And if you're familiar with SP who is active, this tool also helps you to deploy this stored procedure to do some monitoring. Obviously, there is nothing going on right now. I think I can push some, let me see. I think I have a script here. There you go. To generate some load, just to make sure we get some activity and to show you that, let me see. There you go. Connecting. There you go. This is just creating some random connections and just putting some load so we can see some information here. Let's see. I don't think this is enough. So basically, it's a SQL server. It's a SQL server running in a container. I can explore my objects. I can deploy objects, but how do I manage this container? How do I do all the stuff I'm used to do? All right, there is some examples here how to do it using the Azure CLI, but I will jump into the Azure portal. I want to show you how to do it using the Azure portal. So let me go here. This is a dashboard you can create. I have all my services here. Oh, there you go. See, you can see the memory. By the way, this is how you can monitor a container. Here's the memory going up, and it's because I'm doing some stuff. But let's take a look at my container. So my container is ACI SQL Dev 01, and this is so nice. I got like a general overview how my container is doing. It's running, of course. Here's the location, the subscription ID, my public IP, my fully qualified name, everything. You can see that this is exactly the information I grab using the Azure CLI. So it depends on your preference. If you are a visual person and you like to use the portal, you can do it. But anyway, oh, the CPU just jumped. Take a look. And this is really cool. I like this interface because it instantly show you how your container is doing. But I'm jumping things around. Just let me focus on the main thing right now. We'll go back to that point. All right. So if you go to containers here, this is even great because you can see every single event related to your container. This is from the Azure infrastructure perspective. So whenever your container was created, was started and stopped, all those events will be logged here. What about the properties? They are here as well. If you want to take a look at your environment variables and anything else, but I like this, the logs. You can take a look at the logs exactly the same way I did it using the Azure CLI. You can get an access to it, to the logs, and you can even connect to your container from the command line. Let me just address this. I think this is, I can't. For some reason, I can scroll down, but you can connect to your actual container running in the cloud and you can do stuff. I am in, so I can get the host name. The host name is assigned by Azure, but anyway, it's SQL Server. I am connected using the MS SQL user. So great. What about if you are not interested anymore to, have this container up and running, and you can do it from here. But before, let me show you this, the metrics. This is really cool. You can monitor your containers, how they are doing in terms of memory or CPU. I run those scripts on purpose because I wanted to show you some changes. So whatever the application is running on the container, you can monitor using these nice metrics. section. Okay, so what about if we want to stop this container? Let's stop the container because this SQL Server is no longer needed. For some reason, I just finished my development, so I'm done. Great. See, it's done. It just stopped my container. It just took a couple seconds and it stopped it. So what about if I want to start this container again? I just need to click on start. This is going to take probably 1 minute and a half. As I said, starting a container sometimes takes 1 minute and a half to 2 minutes, but it's not the same loading a VM that has Windows or Linux and that has a ton of applications or who knows what running on that VM. And on top of that, you have SQL Server. So this is really quick for me to do some stuff. And you know, as a developer, if you want to take care of something really quick, you can do it. Okay, great. If we go to activity log, let me show you this. This is the last thing I want to show you. No. Overview. There you go. Yeah, here. You can see the drop in the CPU utilization, and it was because I stopped this container. Of course, you will see anything going on for your container here, as I said, whenever you stop it, whenever you delete it, and of course you won't see when it deletes, but take a look here. Here's when I started this container 2 minutes ago, and probably will be up and running in a second. Okay, so enough about this. Let me jump back to Visual Studio Code. All right, so this is what, here's an example instructions how to do the stuff I performed using the portal. The next demo, it's really cool, interesting. I'm really excited about this feature, by the way. Okay, let me just run these commands here. There you go. This is just some stuff I'm using. If you want to follow along these demos, you can just assign any values to these variables. Of course, you need to have a resource group, and there is a name of my ACI and the SA password and my excuse me, my folder. Okay, so this is really cool and new, brand new stuff for you. So as I said, there was some collaboration between Docker and Microsoft, and now we can use all the Docker client commands to manage all our ACI containers running, of course, in Azure. What those mean? So that means that I used to work with a lot with Docker, so I'm very familiar with Docker logs or Docker container run and whatever. So I can switch my local Docker context to use ACI instead of my local Docker engine. All right, so here's more information about it. You need to install the Docker Desktop Edge. This is kind of the insiders from Microsoft, so you will get access to the latest version to use these experimental or preview features. I would say preview. Okay, here's an example of how things looks on the Docker Desktop and the Docker Edge. Just let me close this. And there you go. All right, so we have a traditional Docker Desktop installation on the left, and here's the new Docker Edge. You can see then it says enable cloud experience, enable the cloud CLI support on Docker Desktop. So as I said, that means that I will be able to connect to my ACI context. So let's do it. Where did it go? There you go. So the first thing you want to do is to log in Azure. I already did that. It is super simple. It just prompts website, web page where you have to log in into Azure, and that's it. So let's explore my current context. Let me, this is so small, and of course I can zoom in. All right, so my context right now is pointing to Microsoft Reactor. If you see the type, it says ACI. So it's Azure Container Instances there, okay? And the description is Microsoft Reactor. That's my resource group at West US. That's the region or location I'm using for my resource group. And that's it. And the one you see at the bottom that says default and it says Mobi, that's the local Docker engine running on my computer. But of course, I'm using ACI. Okay. So let me close this down, change my. There you go. Okay. Oh, what is it? There you go. Okay. So here's how you create a context. You need to create this context, of course. So here's an example: Docker context create ACI, and then a name. Then you have to provide a subscription ID. You have to provide your resource group and your location, and you're done. So then you have to run the Docker context use, and you'll switch to the context you want to use. This is very similar to Kubernetes, so I'm very familiar with it. Okay, so what about creating a container from here? So as I said, exactly the same. Docker run, those things that we're familiar with already. And the only change I did in order to create the SQL Server container from the Docker desktop was to include the CPUs and the memory, because when running this specific client doesn't take care of this automatically. When we're running Docker client, you don't have to. You can, of course, but you don't have to pass these parameters. But when you're running SQL Server and ACI, remember, we always need to pass the CPU and memory parameters. So that's done. What about if I want to take a look at my containers running on ACI? By the way, this is an alias. I have an article already published on SQL Server Central. If you want to take a look at those alias to it saves some time. I don't have to write all the thing. Okay, so here you go. So I just execute my alias to check the processes I have running, and take a look at this. From my Docker desktop, I am using the Docker client, and I am checking what are my containers available on ACI. So I have like 6 containers running on ACI. What about if I want to get information about, I don't know, this dev03? I can take a look at the logs from here, of course, using Docker logs. The same stuff I was using ACI and the Azure portal. And what about if I want to connect? Again, I can take a look at my metadata for my container, and I just grab the IP here. I got the IP of my development 03. Let me switch back here. There you go. Sorry, I'm messing around with this. So what about if I want to connect? Again, I can use Azure Data Studio. I can grab this IP address. So let me redo it again. I'll close this connection. Of course, I'm done. And I'll close this. So let's take a look at my dev03. And this is the IP address. The same IP address I have. And that's it. So it's so easy. I like this very much because it's so easy. What about if you don't have Azure Data Studio and you want to connect from your local machine and you have SQL command already installed? You can do it. You just need to provide the IP address and the ACI password, and you can query your instance. Take a look. This is my instance running. This is an empty instance. I don't have any databases there. So what about making a deployment? So let's move to a more interesting demo. Hopefully that was good for you. I like it very much because I can do lots of stuff now. Okay, so the next demo is about doing a deployment. I show you how to deploy an Azure Container Instance SQL Server container. What about using it? What about creating databases? What about deploying stuff into my container using it? Okay, so this next demo is about that. And this is very special because I'm going to use only cloud tools, I would say. I will explain that along with this demo. Okay, the first thing I did to create this container was to create an Azure storage account. If you want to use volumes on ACI, you need to have a storage account. So I created my storage account, and you can see it here. Then I created something called a file share. File share is just like a folder in the cloud. And of course, there is many security stuff you can implement. I just did it really easy and quick here. And then I created a new container and I mounted. Take a look. This SQL files mount point is using the file share I created. So whatever I choose to put on those and that file share is going to be available in my container in this volume, this SQL files volume. Exactly the same stuff here as you saw before, CPU, memory, images, and everything else. I'm just including my Azure account, my storage key, of course, my file share name, and then my container is going to use that mount point. Okay, so this container is up and running already, and this is done. So there you go. What about making a deployment? Okay, the first thing I need to do is to check the container status. I need to make sure my SQL Server instance running on this container is up and running, and of course is running. Okay, I have all I need. I can connect to my container using this ACI container exec, the same way I did it on the portal. And I already created some kind of temporary bash shell profile, so I'm going to use it. There you go. So I want to make sure I am not making a mistake. So I'm connected to my ACI. Remember the mount point I show you. So that mount point has a couple of folders, has SQL backups and SQL scripts. There you go, SQL backups, SQL scripts. Both are empty at this point. Okay. All right. So I need to, for example, I need to put some files. I need to deploy some files, and I need to keep these files secure. And I want, for some reason, I want to copy and paste these files into my container. I can do it from my computer. I can use a new tool, preview, called the Microsoft Azure Storage Explorer. And I already have my ACI file share here. Let me see. Oh, okay, there you go. So remember, I mount these file share into my container. So I have access to the two folders I create inside the container. What about using SQL scripts and uploading a file? Okay, upload the file now. And this file will help me to create a database. I can take a look at the status. This transfer just started, and that's done. So if I switch back to my container and I look at the folder structure, I should have something like this. The SQL scripts should have this file within. All right, so let's take a look again. For some reason I want to double check. Let's run this ls command, and there you go. My file is there. Okay, sweet. Let's create a database. This file is going to create a database called human resources. So let me put this on full screen mode and run this. And now SQL command just took care of creating this database for me. So this is what happened here. It created a new database called human resources. It created some employee table with some data, and it created some employee details table and so on. So cool. My database is there ready for me. I used just these tools to get this done. Nothing fancy. What about checking databases and making sure it's there? It's there. If you can see, I'm just querying the these databases table to make sure my database was deployed. What about if I want to use a graphical user interface like Azure Data Studio again? So let's connect to my ACI 2. Let's take a look at databases now. It's taking some time. Interesting. What about if we disconnect and reconnect? There you go. Oh yeah, there you go. I have like a glitch there. So my human resources database is here. I have my tables and everything else. So it's a SQL Server running on a container. It's the same. I am able to use volumes. I can share files between my computer and a container. Imagine the possibilities. This is just a, I know this is silly. It's a simple example, but it's something that probably can help you to get you started. Okay. All right, so I think that's it for these demos. Let's go back to the presentation mode again. While I do this, just let me get a sip of water. Awesome. I was having troubles with my throat today. Okay. Oh, I forgot something really quick here. There's something else I would like to show you. I won't spend much time because we need some stuff. I have some stuff to show you. What about create a multi-container deployment? Remember, I mentioned this. And for some reason, I decided to create availability group. I wanted to have some read scale. Read scale is a way you can scale out your reads into SQL Server, taking advantage of a availability groups feature. So you can decide to, I don't know, like route read only intent queries to a certain instance. So I need to deploy a couple instances, and that's exactly what I did here. Let me show you the deployment. When you need to, whenever you need to deploy a multi-container solution into ACI, you need to use YAML. YAML is really easy. This is very straightforward. There is information about this template. It's here included. You have lots of information, and also you can use subnet and lots of crazy stuff. So here's the properties and template you need to follow in order to create these deployments. Create deployments like this. So the name is read scale, version of the API, my location. As I said, pretty straightforward. And then my containers. I have two, of course. Here's the master one. Here's my image, memory, CPU, the ports I want to use, environment variables, and the same again. Here is master 2, the metadata about my properties, environment variables, and then you decide if you want to go public or if you want to use a VNet and stuff like that. And how this looks on the portal? Well, simply there we go. Okay, so remember when I show you the standalone, if you will, container group where we have only one container running on my container group, here's the difference. I have two containers, you can see. This is basically the same, I would say, deployment as Kubernetes pods. Very similar. If you're familiar with Kubernetes, we're going to have some example about that, of course, but this is very similar. So you have two containers running here. I can take a look at the events by container. I can take a look at the properties by container, the logs, and even connect. So pretty straightforward, as I said, really easy. You can, of course, monitor your containers here, and it will provide you information about how each one of the containers in this deployment is doing. Okay, now it's time to go back to the presentation. A quick recap of what happened. I show you the Azure portal experience using as well the Azure CLI and using Docker CLI that now it's available. Azure container instances using an Azure file share. It's possible you can mount volumes. And I also introduced you to Azure File Explorer, this nice preview tool that helps you to connect to your storage accounts and do lots of interesting stuff. And finally, a multi-container deployment using YAML. Sometimes it could be overwhelming, but trust me, once you figure out how this template works, it's easy. All right, so the next topic is Azure Kubernetes services. And well, and this is really a certain piece of what Microsoft is doing from the container orchestration standpoint on Azure. Kubernetes was created on this idea of making easy to run lots of different containers in a single platform. So it's not dedicated for SQL Server, it can be anything, okay? People often says that Kubernetes is complex. And well, I would say that probably they are right. And this platform will handle a lot of containers. So obviously it needs to make sure these containers can talk each other, and they need to see each other. They need to do some load balancing. They need to consume storage capacity. They need to make sure they are healthy. And so that's a lot of complexity that you will probably don't want to be fully responsible. It also has lots of moving parts. And there is lots of VMs that can be your nodes, and has an internal database called the etcd behind the scenes. You need to back up that database. But there is always a solution for that complexity, right? And that's exactly what Microsoft has done for you with AKS. It delivers a fully managed experience for Kubernetes to make your journey to this technology easier. Then you can just focus on submitting your manifest files into Kubernetes, and this platform is going to run whatever you ask to orchestrate while maintaining your desired state and getting the job done. So why ACI? So you have many good reasons to choose this Azure service. It comes with a nice management feature around the Azure portal, the Azure CLI, but it's just a matter to change the configuration to scale up the cluster or maybe trigger an update without really having to worry about the tedious infrastructure management stuff. Fully integrated with ACR and ACI. I know I didn't go in much detail about this topic with using ACI, but there's a lot of really interesting stuff you can achieve. You should be able to use AKS to deploy virtual nodes using ACI. Those are called QLEDs, virtual nodes that you can deploy in terms of seconds when traffic comes up, and then just can get rid of them once you are done. Lots of interesting stuff here. So again, it's a fully managed experience for you with automated patching, upgrades, integrated monitoring. It's a fast end-to-end development experience with Visual Studio Code, Azure DevOps, Jenkins, or even more. Okay, so let's have a demo about AKS. All right, there you go. Okay, we're almost there. Okay, so here is a lot of stuff. If you're interested to follow this demo along, I strongly recommend you to take a look at this first. Here's all information on how to deploy an AKS cluster using Azure CLI. Everything you need is here. There's some references here. So I will go through these really quick here. Here's how I created my AKS cluster. I have a couple of nodes, the size of my VMs, the DNS name, and everything else. Once I am done, I just get the context to make sure I can connect to my Kubernetes cluster, and that's it. In terms of the deployment of this infrastructure, what about SQL Server? So I did a couple of deployments here. I created a couple of namespaces. Namespaces are this logical division between deployments on Kubernetes. So I created two. The first one is called Plex SQL. It's a SQL Server instance running on Kubernetes that is going to have some persistent volume storage. I created just one for this deployment of SQL. It is called Plex SQL, and my Kubernetes cluster is called Endurance. So if you're familiar with those terms, you will figure out where they came from. Okay, so Plex is simple. As I said, it is a simple SQL Server. I just have volume. I can connect from here, and then I create TARS. TARS is more complicated than Plex. So let me show you this really quick. The deployment for TARS is ignore it. It's a little bit complex. Here's a I would said no, let me go back here. I would said Plex is like a traditional SQL Server deployment on Kubernetes. It has everything you need. It has the image here, environment variables, and the secret. I created a secret to store my SA password, and I have my volume. I call it MSQL DB, and the mount path is this, and it's done. This is my volume claim. But what about, I have this question really often. What about if I want to create a separate volume for my databases, one for my backups, one for, oh, this is typo here, one for my system databases? You can do it. You can achieve this stuff with Kubernetes. So as I said, TARS is complicated. TARS has these volumes, and here's the user DB's volume, here's the log volumes, and here's the system DB's volume. So I have 3 different volumes to make my data files persistent. So my deployment, it is a little bit complicated here, but it's nothing really overwhelming. Let me go to where did you go? Deployments. There you go. So here's Plex. As I said, it's simple. Sorry, I'm jumping around the wrong file. Okay, there you go. So remember, I created 3 different for Plex. I have these little weird signs everywhere, so I have to fix this. Okay, so I'm using these environment variables to define, okay, my data is going to be mounted in this volume, my log is going to be mounted in this volume within the pod or this deployment SQL. My system DBs are going to be here. So I'm using different stuff, okay? You can go over all this stuff and take a look if you want. Okay, but let's move to something really interesting here. Remember, at the beginning of this presentation, I said that we are looking, if we are running SQL Server containers on the cloud, in this case Azure, we are looking to get connectivity, we are looking to get durability, and we're looking to get a high availability, of course, because these are databases. Okay, so we can achieve all those things using Kubernetes, for example. Here's my Kubernetes cluster. Let me do something really quick here. What would be interesting for you guys to see here? I have some namespaces, as I said. I have Plex, I have TARS. I want to separate things around. I have a couple nodes on my Kubernetes cluster, this endurance cluster. I have node 1 or node 0 and node 01. Okay, I have multiple pods. Those pods is where SQL Server is going to be running. Here's Plex, here's TARS. Okay, I have services. Why I am creating a service? Well, a service is like a load balancer in case of SQL Server. I did this because I need a public IP, probably on a production environment type a deployment. You will like to use a node port, and you want your applications to be able to connect, not anything else from the outside. Okay, let's move to something interesting. Let's take a look at the persistent volume I created for Plex. Remember, Plex is simple. It only has 1 volume. Okay, this volume, this is the description of my volume on Kubernetes. So the namespace is this. This is the name of my volume. I'm using the storage class manage premium to make it really fast. And the volume here, this is the most important part here. Take a look at this volume. It looks like an ID, right? But what is this? So I started to dig around this stuff, and I was able to list all the disks that are part of this resource group on Kubernetes. So I can take a look that I can see that I have a couple of disks that are assigned to my nodes, but I do have this dynamic PVC. Well, what is that? Well, this dynamic PVC are the disks that are presented to my Kubernetes cluster here. So if I want to get the exact disk that is part of my implementation for Plex, I can get it. And this is the disk, this is the side, and it says that it's attached. What about if I want to explore this disk on my portal? I can. I already saved it here. So this is the disk. Why I'm showing this information? Because I want to make sure you'll get what I'm going to do next. So again, I have this volume. I have this volume that is mapped into a disk on Azure. So whatever happens to my pod in Kubernetes, my data should be there, okay? Because this is persistent, and I'm looking for that functionality. So here's the description of Plex, and here's a lot of metadata, but the most important thing here is to take a look at this. This is the volume, okay? The persistent volume is the one I was showing you before. It's the one with the disk. Okay, so let's connect. There you go. I'm connected. What I'm going to do next, I am going to create a database. Remember the database I created from the previous example? I'm going to do it again on Kubernetes. So I'm creating the human resources database. It's there now. So let's check real quick. All right, so human resources is here. So what happens if there is something wrong with this pod and for some reason my container is deleted? So I'm going to do it now. I am going to do this crazy experiment here. I'm going to delete the pod where SQL Server is running, and I will expect my connection to be exactly the same. Let me connect here. Manage my connection to this cluster to be exactly the same, to have exactly the same IP and everything I'm using, because I'm using this service. And I am expecting as well to have all my databases and everything else the same, to be the same. Okay, I'm simulating this, and what's going on here, let me explain once this is done. Done. Okay, so let me explain really quick. We're running out of time, and this is the last demo, but hopefully this is interesting. All right, so this is the start time, and this was my previous pod name where my SQL Server was running. Take a look at this ID. It was running, it was okay, but then I just decided to kill the pod to show you the high availability. So it was killed. It says here that it was force deleted. And what happened? Kubernetes didn't try to resuscitate this pod. It just created a new one. And it was created really quick. And it says that it was running. And then I checked the SQL Server logs to make sure everything was fine. And let's take a look at this. Yes, SQL Server was restarted on a new pod. And this took less than 5 seconds. But what about my database? What about all this stuff that I had there? If I lost my container, what's going to happen to that? So it happens. I might need to reconnect here. There you go. All right, so the IP didn't change, same connection, and human resources is here. What if I want to run some queries and make sure I can connect and everything is fine, because I can probably see it, but I want to make sure Plex is simple. It's robot. So it's there. Human resources, my tables are there. I have data. Data is there. So really cool. Nothing happened. Okay. And finally, really quick here, if you want to do some close monitoring with Kubernetes using the dashboard, there is a really nice dashboard that it's included with Kubernetes. It's opening right now. Let me just jump. That's the last thing I want to show you before we go. I'm going to use a kubeconfig. There you go. Sign in. Okay, I'm in. So if I want to take a look at my namespaces here, now I want to see Plex. Here's some nice information about CPU, memory usage. Here's my deployments, my pods. I can take a look at my services. Remember, everything I did using the command line client, it is also available using this Kubernetes dashboard. If I want to see the pods that are active right now, it's here. It says that this pod is running. It's running since 3 minutes before, and it was because I just recreated this pod when the previous pod was killed. Okay, so let me go back to the presentation. This is the last part we are finishing. So this is what happened during this demo. I was a user connected to a load balancer service. This load balancer service was pointed to pod on a Kubernetes node. Okay, and this pod was pointed to a persistent volume storage. Something happened with the pod, so Kubernetes recreated the pod in the same node, or probably another node, and nothing happened. I was still connecting to my balancer, load balancer service, and the pod was able to get into the data files, and everything was normal. But what about if the node had a problem? So Kubernetes is going to move things around and recreate a pod in a different node, and you will be able to see your data. So really cool. All right, a quick recap. Compute and storage is separate with Kubernetes. I think it was very clear that no matter what happens to whatever the pod running, my data is still persistent. Declarative management, of course, we use these YAML files to find what we want, and Kubernetes is going to take care. High availability out of box, of course, and we have this manage control pane, the dashboard, or we can use the AKS dashboard on Azure portal. Okay, here's a quick review of what we see today. First topic was Azure Container Registry, a platform that provides me a way to build, tag, and push container images into a private repository with geo-replication and lots of interesting stuff available. Then I talk about Azure Container Instances, how you can integrate and run these containers in the serverless mode in Azure infrastructure. And finally, Azure Kubernetes Services, how you can deploy, orchestrate, and you can even scale your deployments in using this platform. So I think it's time for questions. I don't know if we have questions. We were supposed to take some questions, but I didn't check the chat. So anyone wants to drop there? Okay. I'm trying to look at the questions. Okay, I think we have a few questions. Okay, we have a question here that says, whenever I plan for a DR scenario for my mission critical, what are the pre-configuration methodologies should I follow in the SQL Server containers? Well, I think it was explained on one of the demos, and the best way to achieve DR or high availability, because DR is different, is disaster recovery. High availability at container level is out of the box using Kubernetes. So if you follow along the demos, you can take a look at my GitHub repository. You will get access to how to deploy SQL Server on Kubernetes, and you will achieve HA. And there is more. You can even create, I don't know, replicate those databases from that Kubernetes service to a different platform, where it's whatever you choose. There's another interesting question here. Will I be charged for containers alone or container plus SQL Server databases residing in that container? Interesting question. So microbilling means that Microsoft is going to build all resources in that container. I mean, CPU and memory. If you're using a storage account and volumes, of course, you will be billed by storage as well. And in terms of SQL Server, the licensing cost will depend on your implementation. If you are merely using it for development, you can use the development license. All containers are using the development license by default, but if you choose to use an enterprise or the standard, you will bring your own licensing. So a licensing for containers is pretty much the same as VMs. There is more information on SQL Server licensing. If you want to follow up, please send me an email. I will be more than happy to provide you more information about it. Can I pick what version of SQL Server can I install on a container? Yes, you can choose what version you want to use for SQL Server. So far for containers, we have SQL Server 2017 and 2019 available, starting from the RTM based version to a latest CU. The two operating systems supported so far are Ubuntu and Red Hat. So you can choose SQL Server 2017 CU1 for Ubuntu, or you can choose probably SQL Server 2019 CU5 for Red Hat, for example. So it's your choice. There is also a way to retrieve those images, everything that is available on Microsoft Container Registry. So if you want to ping me, I can show you how. Okay. How I can avoid putting the SQL Server SA password in the YAML file where I can be stored. That's an interesting question, and I didn't show you that, but I have some information here. So if you want to put it on a YAML file, you can use secrets, and that's out of the box on Kubernetes. It's here. Okay, so for example, here I am creating a generic secret for TARS. Let me go back to Plex. There you go. So here's a secret for Plex, and it is going to encrypt whatever you choose to put on that secret. On my case, I use this environment variable for the SA password, and I define the endurance was the password. So when my deployment was issued into Kubernetes, my manifest file, it does not include the SA password. It just includes the secret. It's saying value from the secret called Plex credential, and it's going to grab the value. It's a key per value, yeah, and it's going to grab the SA password. Okay, hopefully that answered your question. You can implement secrets for ACI as well, so really cool. All right, have another question. With ACI, how do you manage SQL database backups archiving in case restore request from last week or 6 months ago? The same way you manage your SQL Server instances anywhere. So if you have like, I don't know, backup strategy, you want to take backups, you can use ACI with volumes, have this dedicated volume, implement a job that will back up your database. And if you have a storage account, you will be able to replicate this file share. You will be able to put some retention in place, lots of stuff. I strongly, well, I don't know, but it depends, the implementation. But if this is merely for development or stage, I don't believe you need backups because these environments are created on the fly. And this is kind of the idea, to create this infrastructure whenever you need and get 100% utilization and you're done. Okay, and in case you need to recreate the environment, you can use scripts, and that's it. All right. Yeah, I think those are all questions we have so far. There is one more. No, it's the same. Okay, yeah, I think those are all the questions we have. So thank you for those questions. It's really great. If you want to ping me on Twitter, if you want to follow up something, please don't hesitate to do it. Here's my GitHub repository. Here's a few references. about lots of stuff related to SQL Server containers, related to Docker, related to DevOps. There is some courses that I'm recommending here. But the most important thing, Microsoft Learning. Do you see a couple of things here that says Kubernetes Learning Pad, SQL Workshops? I will have something at the end. There is a couple of. Here's a reference to some of the articles I have already published on these sites. You want to take a look, but here's what I was talking about. Microsoft Learn. This is a free online resource you can always choose to get some free training about this topic and more. Of course, I recently learned that there is a workshop that is going to be given by the SQL Server team and Microsoft SQL Server engineering team. So there is a lot of stuff. Take a look at Microsoft Learn. There is a link here for the administering containers in Azure if you're interested for that. And once again, here's my contact information. You can scan this QR code and it will take you to the GitHub repository. Here's my email if you want to shoot me an email. And I think that's all. And we can go back to.
Thank you, Carlos.
Thank you so much.
This was great. Everyone, thank you for hanging tight and sticking with us for this event. I think it was very informative, and I hope you thought so as well. We shared a number of links in the comments, so definitely check that out. Our YouTube channel will have a recording for this event coming up in a few days. We have a survey if you enjoyed this content, if you want to see more like this, or you want to see some other things covered, definitely submit that survey and use code 7975. We have another event coming up that covers container microservices, so definitely, sign on to Meetup. If you are joining us and you are not from Meetup, definitely either check out a location that's close to you. Right now, with everything happening, all of our events are virtual. So even if you're not necessarily located in the city with one of our reactor spots, we are virtual. So if the time zone works for you, definitely check out that page and sign up. In addition, we have a couple other things that you can follow beyond just the Meetup page. We have our own calendar, which is just this link here, aka.ms/reactor events calendar. That makes it a lot easier to see different events happening at all of our different reactor locations, because depending on the time zone, we also have just localized events that occur there. So you might be able to find additional things. We also promote some of our community organizer events on that aka.ms calendar. So any local events that may not be directly provided through the reactor, but it's, covers topics that we promote, we've included them there. We also have a Twitter, which often will post some coming up events and things like that. And we've recently started a newsletter, so you can sign up if you'd rather, instead of doing the work and having to search around, just receive reminders in the mail. So definitely check out all of those links, sign up where you're interested. Again, we have this survey. If you can please take the time to submit it, fill it out, give us any of your feedback. We're always trying to improve and provide interesting, relevant content. So that would be wonderful. And that is all. Thank you so much for joining us. And that is the conclusion of this event. Carlos, do you have anything else to contribute, or are we good here?
No, I just want to say thank you for the space and the opportunity to be here today. And thank you everybody that just joined it today, or whatever, if you are seeing the record session. And take this opportunity to learn from these Microsoft Reactor events. This is so nice. So once again, just thank you.
All right. And that is the end.